1. Hey, going live is a little unpredictable. Good. So we're at the end of single variable statistics. So mostly in single variable statistics, we're just looking at frequencies of a single variable. So how often we see somebody like that's between the heights of 6'1" and 6'2" and 6'3" and 6'4". And so we're just going to go and do a quick review of Chapter 1, or in other words, single variable statistics. And we're doing it on Socrative. And I've got a couple people have joined me already. The room number, so you go to Socrative.com, and the room number is 249-717. So the very first thing we learned about was sampling. Sampling. Do I sound like Alex Trebek? I hope so. Sample is taken from every fifth person in an enrollment list. And if you remember the nice lady with the British accent, she called that a sampling frame. So what kind of a sample is being taken? If you take every fifth person in the list, you just go down the list and you systematically choose every fifth person. Is it a multi-stage sample, a stratified sample, a convenience sample, a cluster sample? Is it a simple random sample, or is it a systematic sample? So far, 0 out of 2 students have answered. 2 people have answered. And press the how'd we do, and oh, okay, well, 50-50. So it's systematic. So in a systematic sample, you take a sampling frame and you choose like every fifth or every 25th thing for your sample. Stratified sample, in a stratified sample, you might go, and if you were sampling people in a school, you might go to an individual classroom, and within that classroom, you'd sample 5 people. And so what you're looking for are representative strata in each place. So for example, if you were doing it across Canada, you wouldn't want to sample just Toronto. So you'd say, we're going to sample Halifax, Montreal, Toronto, and then you'd choose your samples within those strata. So that's a stratified sample. Convenience sample, if you remember, convenience is just like, yeah, you ask your friends and then tell your teacher what your friends decided. That would be a convenience sample. Cluster, that's where you choose a particular cluster. So you might choose everybody at a particular workplace, for example. Simple random is theoretically the best. Simple random, you find a nice random way of selecting all your samples. Multi-stage is like a cluster within a cluster. Okay, good. Next, 50-50, we're doing all right. Okay, ask for a show of hands if anyone has told a lie. What kind of bias would likely affect the results of my survey? So there we go. There might be a little bit of bias happen if I do that. What kind of bias? So we talked about sampling techniques, and then we talked about the bias. So bias can result from the way I sample things. Bias can result from the way I do my survey. And so what kind of bias do you think might happen there? So if I said, just raise your hand if you've ever told a lie. What kind of bias could we expect? Response bias. Response bias, that's like where response bias would be where everybody who's lied really wants to be included. Response bias might actually be non-response bias. This is where you'd hesitate to raise your hand to say you were a liar. Besides that, if I asked you if you were a liar and then you raise your hand, I wouldn't trust you anyway. So anyways, yeah, so there are those different forms of bias that can result from your sampling type. Response bias, non-response bias. So we studied some of those forms of bias. Okay, next. I've measured 500 soybean plants for their height, and I've prepared a histogram to illustrate the distribution of heights. The histogram only has 7 bars. Why are there only 7 bars? There's 500 plants. Why are there only 7 bars in my histogram? So how come I only have 7 bars? I have 500 soybean plants. What is going on there? That's interesting. They are grouped. They're grouped. Okay, we're only waiting on half of the participants. So they're grouped because they're a group making a clustered sample. So if you said they are grouped, that's right. So quite often we are grouping data, and we have to choose sort of a logical number of groups, often an odd number. Otherwise, it's impossible. Like I could show you where the 500 plants are, but it wouldn't mean much. So a clustered sample would mean I went to different pockets of the field and sampled it. But in general, my histogram, I'm going to be showing the grouped data. That's right. And so grouped data and ungrouped data requires a little bit of work. Is it possible? Oh, sorry. This says it is possible to accurately. No, the question is it possible to accurately determine the average soybean height from the grouped data? Oh, this is a long sentence. By multiplying the middle value of each category by the frequency of observations in the category, and then adding the results together, dividing by 500. Okay. So how'd we do? How'd we do on this? Is that accurate? And the answer is false. Correct. Everybody got it. 100% got it. So this is what we are forced to do when we have grouped data, and we're required to find an average from that grouped data. We take the middle of each group, but in fact, the plants in that group don't necessarily, in each group, don't necessarily have that middle value. And so we wind up with a slightly inaccurate answer, okay? But in general, that's what you're forced to do if you don't have the raw data. Okay, in my soybean plant sample, to find the standard deviation, should I divide by n or n minus 1? So I've sampled my population. I want to calculate standard deviation. Should I divide by n or should I divide by n minus 1? So yeah, I've got this big population of soybeans, trying to find out something about them, and so I've sampled them, probably not randomly. I should divide by n minus 1 because this is a sample, not a population. If I only had 500 soybean plants, then I'd be dividing by n. Okay. Oh, that is really hard to see, but let's zoom in on it. Okay, I hope you've got your calculators, because this is the question here. What is the variance of this population? So this is an actual population, okay, even though there's not very many people. This is a population rather than a sample. So what is the variance here? Yeah, so if you look at that table carefully, you can see that the variance isn't actually all that hard to calculate from what you're given. So what is the variance of that particular sample? So this is a multiple choice again. What is the variance? What is the variance of that population? So variance in the height of that population. So remember how you calculate variance. How do we do? 217 is the variance. That is correct. Okay, so if you look, basically we take the deviation from the mean. So you can see deviation is an entire column onto itself, down the middle, sort of the third column over. The fourth column over, we square those deviations, and then we add them up. We get 1,520. To calculate the variance, we divide by the number of observations. So 1,520 divided by 7 is 217. Okay, and we're dividing by n because this is a population rather than n minus 1. Okay. Here it is. This is another measure of spread. So soybean plants are found to have an average height of 50 centimeters with a standard deviation of 5 centimeters. So there we go. These are, you know, soybeans don't tend to vary very much in their height if you have a look at them. So they have a height of 50 centimeters with a standard deviation of 5 centimeters. One particular plant, very short, 40 centimeters tall. What is the Z-score? And if you remember, Z-score basically tells you how many standard deviations from the mean a particular individual is from the population. Okay, so what's the Z-score of this particular soybean plant? Okay, so how many standard deviations from the mean, basically? And Z-score gets to be something sort of pretty important. And, okay, show names, hide answer. Okay, 2, or maybe even -2 is the answer. So this is a shorter plant. It's got a Z-score, an absolute value of 2, but because it's shorter, it's a Z-score of -2. But if you figured 2, which everybody did, good for you. That's the Z-score for that particular soybean plant. Okay. So I have 500 soybean plants in my sample. So we looked at things just recently, like quartiles. How many plants would be below the first percentile? In other words, how many plants would be in the bottom 1% of height? So I've got 500. How many would be in the bottom percentile? $500 soybean plants. How many would fall below that first percentile? So yeah, how many would be the shorter than, like in the shortest 1% out of 500? Here we go. Somebody said 5 already. I believe it was Cat. Cowboy Cat said 5. Somebody else is coming up with an answer.
Yeah, I got that. Oh yeah, I was going to say that too.
125. Okay. Do we have like, oh no, we don't. Okay. So I've got 500 plants. 5 of them would be below the first percentile.
No, because you were at 1%.
All right.
25 would be a quarter or oh, okay.
So anyways, so we have like, there we go. That's a quick overview of review of the first chapter or the first part of the course, which is single variable statistics. We've looked at sampling techniques. We've looked at bias. There are measures of central tendency, which we didn't hit very hard because you do that a lot in grade 7 and 8. So mean, median, and mode. We talked about ways of representing data. So histograms. There are also bar graphs, frequency polygons, cumulative frequency polygons, which we didn't talk about. And then we looked at measures of spread. So variance, standard deviation. And we didn't look at box plots when we did our review, but box plots are sort of a construction thing. So there's a quick review of chapter 1, or the first part of the course. All right.